Good morning, everybody. It is 9:30. We're going to get started here. So 4781. All right. Let's see here. Okay. So now let's take a look at where we are. We're at January 26th, looking at lesson 17. All right. So your obligation is obviously is to complete 17 if you haven't already. Some of you are ahead of the game. Now you also remember to do the quizzes, okay? So you also have now quiz 3. That's covers 1-6 and 1-7. As you recall from last week, hopefully that 1-6 was about probability. Well, today is about scientific notation. The section's called bad debt, or it says debt is bad, chocolate is good, and it is about, like I said, scientific notation. And debt is, in the United States, it's very large, as you know, because we take on a lot of financial obligations as a country, I suppose, and it throws our country into a lot of debt. Um, we also have very small, like chocolate, it's made up of a lot of different elements. So, when we break it down into its molecular structure, so we can go ahead and use scientific notation to break that down, to use a microscope, for example, to break it down. So we're going to go ahead and take a look at the lesson directly. I'm not going to bring in the book today. It does teach you, however, I mean, I can show it to you briefly. It does show you some of the methodology to go ahead and to cover how to do scientific notation, how to write large numbers in scientific notation. It gives you the direction to do that. I'm going to be verbalizing that today with you during the process, as well as it does say writing small numbers in scientific notation, and it gives you some practice on that, converting each number to scientific notation, and then it does go over converting from scientific notation to decimals. All right, so this is the heart of the lesson today, and it's really important to understand the application of this. All right, so like that, I'm going to go ahead and talk about it. I'm going to go ahead and address the conversation through Alex's conversation right now. All right. Now, with, again, writing scientific notation into standard form or standard notation, it's looking at a number between 1 and 10. 3 is 1, in between 1 and 10. So what this has us do is take the decimal point, which is located after the whole number 3, and move it, if it's positive, to the right 1, 2, 3 units. And there's our answer. That's how easy this is for scientific notation. So our answer is 10,000. It is not hard. If it was 7, you move it 7 times. So now if it's negative, like this is, then you move it to the left. So you locate the decimal point and move it to the left. 1, 2, 3. Now, if technically you're supposed to put a 0 here to represent the whole number. So if you look at it, there should be 3 zeros in front of the number that's indicated. And imagine this was 2.345892563. I mean, it don't matter. It would be 0.0253346789, whatever I just said, right? It doesn't matter what the numbers are. I mean, I just obviously didn't state the same exact numbers. But anyway, we're going to go ahead and put our number here. It's pretty easy. So movement of the decimal place. Now we're going ahead and looking at a number such as 1,983, and we're moving the decimal point 1, 2, 3 units in order to get the decimal between, or the whole number here, between 1 and 10. Basically, that's what we're aiming at. And 1.983 is in fact between 1 and 10. And how many times did we have to move the decimal place? We had to move the decimal place to the left 3 units. Because we had to move it to the left 3 units, we're going to add 3 to the value of this. Okay? Another way of looking at it is if the number is greater than 10, or I should say 1, then the value is going to be a positive exponential power. I mean, that's just one way of thinking about it. So here they give you this thing in the palette, so you can go ahead and just do 1.983 and then just throw in the exponential power. It makes it a lot easier when they have this as part of the palette. So pretty easy, right? Now, if the number is here, it goes like this. All right, we're going to go ahead and move the decimal point 1, 2, 3, 4 units. Remember what I said before, if there's 4 zeros, then that's going to tell us what the number is with a negative sign. So it's going to be 7.375 times 10 to the negative 4th power. And there's 4 zeros. It's really easy to do that. Oh, it's kind of a nice little trick. So we're going to go ahead and put negative 4. Make sure our number is all right. Done. And 7 is between 1 and 10. All right. So I'll continue that one more time or 2 more times, whenever it takes. I'm going to immediately go ahead and put the number or the decimal point between the 1 and the 4 times 10 and just count. So it's going to be 6, 7, 8. And then that's my answer. See, I can go ahead and write the answer real quick. Oops, probably easier if I did this. Hit that button, right? So then that's going to be 8. 8, not 8, 3, 4, 5. I apologize, my counting is off. It's 3, 4, 5. All right, that's better. I don't know how to count. How did I count 5? You know what it is? I know what I did. I mean, but can't tell you what's in my head. That was a little bit. I don't even know how to count. I picked that up though. I didn't get it wrong before I put it in wrong. That would be bad. All right, now a certain solution has a hydrogen ion concentrate of this. All right, and it wants us to what's the question? Write the number in standard notation. So writing that in standard notation, we'll get those 4 zeros, and then 9, 14, and then a blue whale can weigh 420,000 pounds, right, in scientific notation. And that is, let me count now. This is 3, 4, 5. You know, you got to make fun of yourself sometimes. Like, where did I go wrong? Why did I do that? I mean, I pick it on myself, but not that I'm making fun of myself. But. All right, now, we have multiplication. Now multiplication, what you want to do, now this is a good strategy I'm about to show you here. All right, and that is group your numbers together and multiply them together. And then go ahead and put the multiplication symbol in there because it's part of the scientific notation. And then go ahead and bring these together. The tens with the exponential powers. Now, when we look at this, all we're doing is taking our calculators. All right, we can punch it in. But I mean, I think you know what 2 times 4.4 is. Well, I mean, so we're looking at 8.8 times 10, and then we add our exponential powers here together. So 7 plus 8 is 15. And then that's our answer. And if it had been a -7, then it would have been -7 added to 8 would have been 1. All right, so you got to watch your signs and things like that. All the power of integers still take effect. Now, the thickness of a math book was 2.8, and we look at kilometers would be very, very large. That would be extremely large. Millimeters would be very, very small. So it's got to be centimeters. Now, write the scientific notation of this. So now we're talking about the scientific notation. Now, it wants it in meters. Goes from centimeters to meters. Now, I don't know. It's hard to imagine, but King Henry died, unfortunately, drinking chocolate milk. And it's the unit of measure is meters. So it's going from centimeters to meters. So it's the decimal point is moved over twice from this. So we're looking at 2.8 centimeters is now turned into 1, 2 units. All right, into meters. This is how many meters we have. So it asks us to do a conversion for, and if you don't know your conversion of the metric system, you're not going to be able to do this. So King Henry died, unfortunately drinking chocolate milk is an acronym. It's like a little phrase that we use to remember the kilo, hecto, deca unit of measure, which is meters, liters, or grams, deci, centimeter, I mean millimeter, excuse me. And deca is normally DA, by the way. But anyway, so since we're moving it from centimeters to meters, we move it 2 times. This is the number in meters, and it wants it in scientific notation. So it's going to be 2.8 times, and that's going to be -2. All right? Because that's the only way you can go from centimeters to meters. So the length of an apple seed, apple seeds are very, very small. So this is going to be millimeters. All right. And then scientific notation is 1, 2, 3 units. So then it's going to be -3 here now. Versus a -2. And it's all because I'm following this little, phrase here or a setup. Now for division, we treat it as this times, and then we're looking at 10 to the 6th divided by 10 to the 4th. Now, when we take and calculate the quotient of this, we get 7 divided by 5, we get 1.4. All right, so 1.4 is what we calculated that to be. And now when we bring this up, we subtract the 4 from the 6. That's how easy it is. So it's 6 minus 4. And we're always going to put it as 10 to some power. Now, every time you add division, you subtract the bottom from the top. when you have multiplication, you add. All right, so then you're going to get 2, right? Because 6 minus 4 is 2. So our answer is 1.4 times 10 to the second power. Now, if it had been 4 up here and 6 down here, 6 would have came up and made it negative 2. All right, so depends on which one's more negative, or which one's greater, I mean. So we look at this. We have 4.5 divided by 5. And then we have times, and then it's 10 to the negative second divided by 10 to the negative 6. Now we take our calculators and do 4.5 divided by 5. All right? And 4.5 divided by 5 is equal to 0.9. And if we bring up the 6, right, it becomes its opposite. So it's going to be negative 2 plus 6. And that's going to give us 10 to the 4th as well. Now, the problem here is that we're not between 1 and 10. We're between 0 and 1, but not 1 and 10. So what we have to do is move the decimal point over 1 time to the right. Anytime you're moving to the right, the decimal point, just like when we had this situation, let me see. I can't think of it. This one's moving to the left, it's adding. And here's something. Okay, now see how we moved the decimal point 1, 2, 3 units, and we get negative 3, and then it would be 2 to the negative 3, or 2 times 10 to the negative 3. It's hard for me to explain it in this terms. So what I say to you, anytime you move it to the right, you're subtracting that many units from the exponential power. And you have to do that because you got to get 9, all right, to be a number, or to get this 0.9 to be a number between 1 and 10. So we have to go ahead and move the decimal point over 1 time to the right, and then we're going to subtract 1 unit from the exponential power. So our answer is 9 times 10 to the 3rd. That was a little confusing. If you're confused, you're not alone. Absolutely not alone. That one's absolutely confusing, because they didn't give us a number that was clean. It wasn't so easy because they go ahead and made it 0.9. Had it been, let's say, 90, then we would move the decimal point 1 time to the left, and if we're moving it to the left, we would go ahead and add to the exponential power. I mean, I really hope that that's understood, and it sometimes happens. And here's an example of that happening. Here we have, all right, 6 times 7.2. We're going to get 43.2 times, and then you could do it in your head, 10 to the negative 15th, right? Because both more negative. We're going to add them, and it's going to be both negative. So now we have to move the decimal point over 1 time to the left. So we can get 43 to become 4.3. Now, because we move it 1 time to the left, we're going to go ahead and add that many units to the exponential power. So what is negative 15 plus 1, right? And that's why we get negative 14. Again, that takes a little practice. This is being recorded, so if you need to review that again, by all means, review it. The key ticketed item was, if you have a number greater or less than 1 to 10, then you have to move the decimal place. If you move it 1 time to the right, you're going to subtract that many units, or how many ever units you need to move it to get it between 1 and 10, but in this case 1 unit. You're going to subtract 1 from the exponential power. If you have to move it to the left, like in this case we moved it to the left, all right, then you're going to add exponential, that many exponential powers. That's kind of hard to think about, but it's possible for you to recall it if you just do it. All right, now the rest of this is pretty straightforward. This is scientific notation. So how many zeros? I see 4 zeros. So that means I'm going to get 7.73. And then it's going to be -4 because I've seen 4 zeros. Kind of an easy strategy there. All right, this is 2.59. I had to move the decimal point over 2 times. Therefore, I have to put 2. All right, I see 3 zeros. So look how fast this is moving. Make sure you put the negative in there when you see 3 zeros. All right, and that concludes this lesson about scientific notation. All right. Are there any questions on scientific notation? All right, well, in which case, then I'll stop the recording.